What's up, young mathematicians? Thank you for stopping by here at Tau 2 Pi. I am Caesar the tutor, and today we're going to be finding the domain and the range of a function when they give us a graph. When they give us a graph, it is the easiest thing to find because they're literally giving you the answer on the paper. All we have to do is follow the arrows and look at the directions that they want. Whenever they want to talk about the domain, we look in the horizontal direction. How far left and how far right does my function go? And when we talk about the range, we're asking how far down and how far up does it go? And all we have to know are any little changes or breaks in the function. When they draw the graph, the most interesting parts of the graph are going to be drawn on the paper. And you can assume that everything that's going on at the ends continues exactly in the same way that the arrows left off. So the most important part of the graph is going to be the middle part. And that is the part that we have to figure out whether it's going higher, lower, whether it's going to hit a maximum, whether it's going to hit a minimum or not. But when we're given the graph, we're actually given the answer on the paper. So let's take a look at how we can identify domain and range given the graph. Let's start with a few examples of finding the domain and range of a function given its graph. Looking at the first graph here that I have is f of x. Now this appears to be a line. We have arrows at either end, which indicates that this line keeps going on forever in that direction and forever in this direction. So that's actually going to be the easiest case. And for the lines, remember, for any lines that keep going forever, the domain is going to be all real numbers or negative infinity to positive infinity. And we're going to write it like this. So that was easy. Now let's take a look at the range. Well, same thing with a line. As long as it's not a horizontal line, the line is going to have a domain of all real, a range of all real numbers. So it goes all the way from negative infinity to positive infinity. So we're going to write our range as negative infinity to positive infinity. So that's the easiest case. And in general for a line, the domain is going to be all real numbers and the range is going to be all real numbers unless it's a perfectly horizontal or perfectly vertical line, which we'll go over. Now looking at h of x over here, it's another weird function now, but clearly we can also see that it's going to go forever in that direction. It does whatever it wants over here and then it goes forever in that direction. So domain is going to be all real numbers and the range is also going to be all real numbers. So remember, for the domain we look at the direction in the x and for the range we look at the direction in the y. So let's go ahead and write this out. Domain negative infinity to infinity and range negative infinity to infinity. And now let's look at this example over here. Now for this one, the domain seems to go from negative infinity to positive infinity. So the domain goes all the way that way, all the way that way, so we're still good. Negative infinity to positive infinity. The range, however, the outputs that we get out of this function, literally the points that are being graphed, are all above the x-axis. So therefore, it's all positive. It does start at 0, so we do have a range that starts at 0, but you can clearly see that that arrow moves in that direction, this arrow moves in that direction, so the range is going to be 0 to infinity. Now let's take a look at a couple of other graphs where the domain and the range are not as nice as the last ones we saw. R of x is a weird graph. It's actually a piecewise function. Now let's take a look at why it's a function. There's a couple of things going on here. First we see an open dot here, and then there's a jump or gap, and then we go up to that other value up here. This one is an open dot, that one is a closed dot. So whenever we perform our vertical line test, we are only hitting one point, which qualifies this as a function. Now, let's take a look at what my domain could be. Starting all the way from the left, we could see that this function continues going all the way to infinity in my domain. So we're going to say the domain is negative infinity to somewhere. We still don't know where it finishes. Well, we know it's going to finish somewhere around here, but what's going on over here? Well, if we continue tracing points along the x and then getting points along the y, we see that once we get to -2, instead of getting that point, we're going to get that point. So that's fine. It's still good. It's still good. And then it stops over here. And that value is +2. So therefore, our domain goes from negative infinity all the way to +2. And we include 2 because there's a close dot there. Now the range is the one that's going to seem a little weird. And for the range, we have to look at our y values. What are all the possible y values that I can get? So, well, starting from the bottom, we know that it comes from negative infinity all the way up. So we're going to start there. Let's start with negative infinity. At least we get one value out of the way. Now, it comes up to this value here, and it has an open dot. And we see that there's nothing between these 2 points. There are no y values here. So therefore, this one is going to stop at this y value. It's going to start at negative infinity, and it's going to keep going up, up, up until it hits -3, and that's where it's going to stop. And we're not going to include -3 because there's clearly an open dot there that they do not want us to include. So we're going to say this one's going to stop at -3. But then we need to add the other part because this function also returns values from that value to that value. And this one's 4, and this one's 5. And we know we're including 4 because there's open dots in 4. And we know we're going as high as 5. And we are including 5 because there is a dot there. It's not an open circle. So then we're going to say, we're going to add the other part. We're going to add the 4 all the way to the 5. And we're including both 4 and 5. And then we're going to put a union here because we're letting the reader know that these 2 sets belong together in the range. And now let's take a look at this one over here, because sometimes you're going to see it like this, or sometimes you're going to see it with the other couple of lines that I'm about to draw. But this also seems like a weird function. It starts at negative infinity on the x, keeps coming down, and then for some reason, it doesn't pass this thing. It kind of goes this way and goes down. I guess the way you can imagine it is if this was a globe, you could think of this value as going around and then going all the way around because it goes all the way to infinity. And then once, hypothetically, once you finish infinity, go all the way around and come back, then you come back on this side. But there is no reaching infinity. So this is going to continue going on forever and is never quite going to touch that value. So what we call these asymptotes. And asymptotes happen when you divide by 0. So that right there is called an asymptote. Hopefully I'm spelling this correctly. Asymptote, yes. And so my domain is going to have a cut. It's not going to touch this value. So we're going to say domain. And we're just going to say it's going to go from negative infinity. And as it approaches 3, it doesn't touch it. So we're going to say it's going to get to 3, but it's not really going to touch 3. But then we have to include the other side. So we're going to go from 3 all the way to infinity. So we're going to say union 3 to infinity. A good way to remember this, and a good way that I usually remember this, is if my graph has a jump, then my domain is going to have a jump over. Have to jump over something, I guess. That's the way I visualize it. So that's the way that it makes sense to me. But now let's look at the range. Now the range is the same thing. It starts at negative infinity, it keeps coming up, and then for some reason it misses that value, and it's doing the exact same thing. It doesn't want to touch that value, the 2. So therefore, going by what we said here, starting at negative infinity, approaches 2, jumps 2, and then goes all the way to infinity. So starting at negative infinity, approaches 2, jumps, and then starts over from 2 all the way to infinity. And finally, the last two examples that we were going to go over are going to be the horizontal line and the vertical line. Let's take a look at the horizontal line first. Well, we know this value is negative 3. It could be anything. It could be 5, whatever, but it's still going to be horizontal. And it goes from negative infinity to positive infinity. So my domain is pretty easy. But the range, it only has one value. It starts at negative infinity, but it doesn't have anything at negative infinity. So let's start at negative infinity, and then we're going to touch one value here, and then we're not going to touch anything else after that. So my range, in the range, we're going to write it in set notation since it's only one value. We're just going to write with these little curly brackets, and we're going to say that the range is simply negative 3. On the other hand over here, we don't have a function. So they're not really going to ask us to find domain and range of this line because it's not a function. If you think about it, the vertical line axis is every single point on that line. So it's not a function. But if you want to remember how to write the equations of these lines, well, if we have this value as, say, negative 4, then this would simply be the equation x equals negative 4, letting you know that it's always going to be negative 4 no matter what y you have. In this case, if you forgot how to write this line, then we look at this value and we say that f of x or y, whatever you prefer, f of x is always going to be negative 3, no matter what x I use. If I put a 4 in here, well, this doesn't depend on x, so I can put a 4, which x equals 4, and I'm still going to get a negative 3 back. That point right there. I could also put a 10, which is way over here, and I'm still going to get a negative 3. So if I put an x equals 10, I'm going to get a negative 3. So that's how this works. That is all for today. I hope you learned something. I hope you liked the video. If you did, don't forget to click like. Don't forget to subscribe if you want to see more content like this. And if you have any questions, comments, concerns, or emotional outbursts, drop them in the comments below.